Bienvenidos nuevamente a Infeal, su compañía especializada en soluciones innovadoras para Green Data Center. Recuerden que contamos con cobertura nacional para atender sus requerimientos. Hoy vamos a tener una conferencia con el ingeniero Don Beaty, fundador de la TC 9.9 de ASRA especializada en Data Center. Espero que la disfruten y aprendan mucho. Muchas gracias.
This is very important because it stops us from thinking foolishly about whether we can or cannot do anything. Engineers, what we really know is that the key to success is to understand mixed air conditions. 2 air streams coming in and 1 going out. That's what we need to understand. So you tell me, if I have a discharge temperature of 58 degrees, and I bring that back to my air conditioning unit is really working hard, isn't it? But if I take 58 degrees and I actually cool it with outside air that's 40 degrees C, I reduce the load by that 18 degrees C. So there's really some significant opportunities regardless. And so that's really an interesting thing. This slide here is really powerful. This is a slide that shows a 4U, and do I have that listed here, right? This is a slide, we got to give IBM credit for this. This is a slide showing the last 4 generations of a 4U server, where they repopulated the server based on making the performance 100% consistent. So we look here, 100%, 100%. All the way through, they're all 100%. The power of this generation 1 to 4, if we fix the performance to be constant, look at the size of the data center that's necessary and the amount of density. And what some people say is that we're getting sloppy, because you see here the power per rack, 100%, and it's gained by 19%. It gained by 19%, but look at the number of racks is so much smaller. It's really a significant drop-off, and so great performance. So these are the kinds of things that are really going on. So now here are the case studies, and so here's this first one. You can see this kind of goes here forever, so to speak. All those racks in there, so you see them going along, and we go ahead and we look. And so this particular one is going ahead and it's organized to where the cooling plant is outside and the power plant is outside. And in order to do speed to market, we located the power and the cooling are located on opposite sides of the building. So that the power and the electrical and HVAC contractors work in different areas at the same time. Speed's really important in a data center. So now we go ahead and look, and this just has an embedded hot aisle and a fan coil on top, and so that's a closed circuit type of cooling system. And here shows what I just was talking about earlier. What I was talking about earlier was bin hours. So this happens to be a plot at the wet bulb level because it was wet bulb cooling. And look at the small amount of hours where the wet bulb does not conform. And so that's the amount of cooling you really need to do. You can size your plant based on that small amount of bin hours. And all these have been in operation a number of years. This is all solid performance, not conceptual. Here is another one, and this is where we've got these existing crack units, and here was the crack unit performance, and here we go, and this, I wanted to show this one just to tip you off. I don't know that you'll run into this here, but as soon as you get to any sort of size in a data center, you have to be really careful about microclimate. The cooling towers, let's say there's cooling towers or air-cooled chillers, they start to create short-circuiting and an overall environment that's different than the ambient. And therefore you have to plan for that, simulate it, and derate accordingly. And same thing with the generators. This is a generator yard, and that was existing, and we proved that that was not going to ever fit the need. And here are the air-cooled chillers and the same sort of thing. And so here it's just using the supermarket curtains kind of thing in order to go ahead and safe it off and change the controls a little bit, and then it does fine, and it went ahead and did these big savings. Here's one, and this is one analyzing the difference between, it's an existing building to be converted to a colo, and the analysis is on whether to do it with air side economizer, water side economizer, or what to do. And here we look, and we see here that we have a wet bulb plot and a dry bulb plot in order to go ahead and try to understand what it is. And we go and we look, and here shows the different bin hours for free cooling, the percentage of the year, and the PUE. And that's the way to analyze things to try to figure out what that cost benefit is for any given type of situation. And here again, it shows that those excursion hours, and those excursion hours being a small amount outside the ASHRAE envelope. And then these are just the summary of that. And here's number 4, and this one is using water off the Bay of Finland, and it's just once through cooling. The air comes off of the water comes off of the bay into the servers and then out. And here shows those same sort of plots, and that's all the cooling plant is. It's just heat exchangers and pumps. That's all that's involved. So in closing, the ASHRAE is a quotable source, and if we think about it in the right kind of way, we could save our clients a lot of money. And the data centers, typically the IT equipment is replaced every 3 years or so. IT equipment is usually worth the same amount as the whole facility, and therefore every time there's a refresh, there should be consideration for what the cost is for the refresh, and maybe it involves a plant upgrade, and maybe it doesn't. And I understand that I've heard from some people that things have changed here as it relates to the level of design that happens here. It's getting more detailed. So here's an example of simulating. This is using Revit BIM, and this is an example of simulating a refresh and part of what's going on in the industry. And so that part is called, some people call this rolling rack. Rolling rack. And the reason for it is because of the cost to, they call it rack and stack, right? To go ahead and insert servers in the rack and the cost for that. So there's some movement towards configuring a whole rack, have it on casters, and roll it in. And when you go and you design, you need to figure that out, whether it can fit or not, and start to simulate what happens at each refresh. So here you go, here's a rack. And so we go ahead and we look at this rolling rack. And first of all, we're showing the airflow. So you can see that, the cooling coming in. So we got some animation with the cooling coming in and the hot air going out. But watch. Look what's going on. I'll slow this down. So here we go ahead and we have bus plugs above the rack for easy replacement. Now watch. Watch the animation of the cables. So it's actually showing the cables being disconnected. And now we're zooming out. We go, okay, let's roll this rack out. And we go ahead here, and we push it down the hall, and we go down, and we go out, and we go across, and we go in, and there's a truck, and we roll it up into the truck, and then we go ahead and we roll another one in, and we roll it on in. And so as we go on, the designs need to get more detailed. They need to get more animation to simulate the kinds of things that are going to happen in a data center throughout its life as it relates to the refresh rate, as it relates to the kinds of changes that will happen. So for example, if it's going to switch to liquid cooling, then to simulate a pipe being navigated through the corridor or through wherever it needs to be in order to get to where it needs to be. And this is the power of today's environment. Now we're going to go ahead and we connect it up, and we're in business. And with that, I am finished my presentation, and I'm ready for any sort of questions.